All right, here we are. So it's really awkward to start this meeting like this every time. Anyways, um, okay, so obviously since I'm the only one doing anything for now, I'm the only one sending ideas about things we should discuss. So what I no, somebody had other ideas.
I was just Louis shifting his chair, I think.
Okay, so I worked not as much as I wanted, but I did some of that work on cleaning API and SPI things up, and shifted to the cache manager configuration bits, right? So what I did is I got rid of the stuff that we had in there, which was around configuration builders. We now have directly cache builders and cache manager builders. Then internally, I actually do build a config, and that then use that config to build to build a cache manager. So let me show you a bit what I did. Let me try something. So if I do this, I guess you guys can see my browser.
Yes.
And if I do this, wait, if I do what? If I do this, you guys can see my IDE?
Yes.
Yes.
Well,
All right.
we can see a syntax highlighted text editor, but I think that's all we're supposed to be able to see.
Right, it's in IntelliJ like presenter mode because that's on my big screen. So otherwise, I think the font would be like really tiny.
Okay.
All right. So the first thing that I did is that I realize this mode is totally not useful for what I'm trying to demo here. So, all right. So basically, the cache builders themselves are in the core module, but the cache manager implementation are in the implementation module. Again, I think this is useful for clustered use cases, right? Where things might be slightly different, I think, maybe. Anyways, all can be undone. So this comes with this weirdo thing that implementation depends on core, but not core and implementation, obviously. So I kind of took the 107 approach. Yeah, I did that. And introduced this like Ehcaching or whatever thing that's using the service load stuff to decide what's going to build cache managers, right? I think it's good enough it decouples. So if we want to have, so obviously, right, this is all being done.
It's the interface in Ehcaching.
Well, yeah. How about that? Right now, it only has a test one, anyways. And yeah, so yeah, I realize I'm not happy potentially what I've done there, and now I remember why I did it this way. Anyways, let's say we keep this way for now. I don't really know, but anyways, the important stuff is the way that we create something is you just create a cache manager passing in the all the configuration bits in it, and the service provider. The service provider, we just knew it inside the build thing, right? So basically, the cache manager, as we said, like is this entity that acts as a repository to caches, but also as a life cycling resource and services pool of some kind, or repository himself, whichever way you would like to call that. Does that make sense what I'm saying?
Yes.
And that's what the service provider is, right? So the service provider sits there, like knows about all the services, how they need to be configured and whatnot. So we just knew him there, and you happily move on and you do stuff. So one thing that happens when you create a cache manager is actually it also creates the associated caches. Okay?
Okay.
Now, we did say we wanted to toy with the idea to have like cache manager less caches in the 3x line.
Yep.
Which means that all of a sudden they lack a service provider, which is usually sourced from the cache manager, right? Basically, a cache manager less cache is not a cache that has no services. It's a cache that is not lifecycled and isn't
Well,
that
whose
you
life
can't look
cycle
up
is
in a
not
cache.
controlled by a cache manager.
Right, but control is lifecycled, right? It's the starting up, the shutting down.
Well, the cache may have a life cycle, but something else has to drive it.
Right, that's actually so. Oh crap! No, it makes me want to. So yeah, I did say this will touch into lifecycle and stuff, right? So a cache is closable in 107, right? Oh, we may. All right. So here's a question. So lifecycle wise, no, let's start with the beginning. So if I open Cache Builder, right? So what the Cache Builder does, it builds something, either knowing a service provider, that's the method, which is not public, that a cache manager will invoke when it's creating stuff, because it's injecting the service provider that he wants this cache to use, right?
Mm-hmm.
Then whatever that then creates, it's not his problem. The important bit is that we pass this thing into the whole system. So a bunch of things happen there, right? By the way, including like the thing that's going to create a cache is actually looked up through the service provider logic. That's how we had it prior to that.
All right.
Now, if you want to build a cache yourself, a cache manager less cache, you just use a cache builder, and you invoke build on the whole thing, and that creates again a new service provider, injects it in there. This misses the config bits, but these are the ones that I'll be working on next. The first one being the capacity stuff. So you inject that in there, and it just uses that, right? So it has its own services that it can lifecycle itself, start, shut them down, and blah, 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 and whatnot. So that becomes funny in this case. Well, funny, for lack of a better word. But basically what we do is we look for a cache provider service in order to create the cache itself, right? And this thing has a release cache on it. It's actually nothing does anything with this as of now, because is this true? Yes, because I think the GC is all we need. But basically, you end up in a situation where if the cache is cache manager less, right?
Mm-hmm.
You created this cache. Now you want to like shut it down, close it, right? You want to basically say, all right, I'm done with this thing, and it can, whatever you need to do, now's the time to do it, like close file descriptors and all that stuff, right? Say it's a disk that uses, a cache that uses disk. That's what it needs to do. So so as you can tell, the culprits are both Chris and I. When we did all this, all the services were responsible for releasing the resources that they allocated during the create, right? So you see this is symmetric, right? There is a create and there is a release. Now in this case, what I need to do is that the cache that this create returns, this will not actually really be released. It's going to be the cache itself that's going to, like I think if I use 107 wording, when you close the cache, you will want this to be invoked. So the thing can invoke that on themselves. It's fine. We can do this. It seems like a weird catch-22 thing.
It's weird that the cache should have to care.
Yeah, it's weird, but so it could also be that this is that is very specific to cache providers, and basically when I ported all this from its initial form, I made the cache provider like extend service, because that's the way we had it done in this prototype we did years back. It doesn't have to be that way, right? So the cache provider is a very like weird service. It's
right.
It's yeah.
I mean, I don't know. I haven't dug through this stuff as much as you, but it feels like if we want to have, so I'm going to step back from some of the detail you're talking about and talking in generalities because I don't grok all the details that quickly. But maybe there's something useful in my vague rambling. It feels like it feels like generally if you want to have a cache that's independent of a cache manager, that what you're saying is the cache manager does, like we said, it does a bunch of things. It acts as a repository for caches. So obviously, if cache isn't part of cache manager, it's not retrievable. That's fine. But it also is responsible for controlling the life cycle of all the services that the cache uses. And implicit in that is the understanding that if those services are being used by multiple caches, then how the life cycle of those services interacts with the life cycle of all of the caches is something complicated that the cache manager has to understand how to work. And that it's also responsible for life cycling the caches in some sense as well. And some of that might just be sort of call through from what the user's asking to do, and some of it might be, you're shutting the cache manager down, well, I should shut all my caches down, kind of thing. But it seems like if you want to have a cache independent of the cache manager, then all those roles that the cache manager is fulfilling should be handled by the user. So the user should be, whatever services the cache needs, the user should be providing. The life cycle of those services, user's problem.
Wait a sec. Yeah. Well, when you say user's problem,
well,
what exactly do you mean?
Responsibility.
User's problem responsibility to life cycle them?
To do everything with them. The cache shouldn't have to. Yeah.
That's horrible.
If the well, no, hang on. Let me finish.
Okay.
So, and likewise, life cycling the cache, user's job. You choose to split it, and so as long as you have, so basically what it means is when you design the API through which the cache manager manipulates the caches, both creates them and life cycles and runs them and so on, it just has to be designed in a way that it can be used. Basically, you want the cache manager to use the same API to talk to the caches as a user would in an isolated sense. Now, the reason I think it's not a problem that because when you hear,
well, is that true? For instance, well, that a cache manager can
when you hear the phrase, well, the statement, you have to handle all the services the cache needs, right? I don't think that's a horrible thing, because to me, there's a bunch of there are ways you can there are a bunch of sort of truisms, statements you can make about isolated caches that mean it's not a problem. So, for example, it's unlikely that someone that creates an isolated cache is going to want it to be persistent. I'm not saying it's impossible, but lots of people who are creating these isolated caches are going to be doing it because they're creating some sort of local in-heap or transitory thing that only exists for the life cycle of JVM. Now, that's not to say you can't create one that's persistent, but I think that's not a common case. So I think in a common case, there will actually be relatively few external services consumed by the cache. And for example, it's unlikely that if you have cache manager or cache managerless caches,
a cache writer. Cache writer is a service. So it's exposed and it's life cycled. We want to have writers being shut down.
Right, but to me,
well, okay, let me rephrase.
No,
maybe the cache writer itself isn't really a service, but there is a service that provides a cache writer to the.
Right, but I don't think the user has to care about that. The user, so the API that the cache manager would the cache manager will know about the service that provides cache writers.
Mm-hmm.
But the API that's connected to the cache will just take a cache writer.
Right, totally. Now, but who's then responsible for starting?
So you want to create a standalone cache that uses a cache writer? Hand it a cache writer.
All right, and decouple it entirely. So yeah. We got the services that create stuff, right? So in this case, we had the cache provider, which is a service.
But the cache doesn't need to know about those.
You could have a cache writer provider or whatever, service that makes sure that basically it goes look up your data, your database connection pool, sets it
Yep.
all up or whatnot, and then also shuts it all down properly.
Well,
But the only thing it will actually provide to
right.
caches are ready to use
writers.
writers.
I mean, here's the thing: if you were designing an API for, if you said screw cache managers, we want to have a cache managerless API. To me,
It's scary for other stuff.
yeah, I know. The panacea for cache managerless caches is to have an API that doesn't even look like cache managers exist.
All right, so cool. So let me call into like, let's say we like that.
Well, I mean, it's a panacea. I don't think it's necessarily achievable. There's going to have to be some give and take on both sides. But
all right. So in terms of there's a bunch of things that go through my mind now. So the first one, let's go back to the simple lifecycle stuff. So this close method or whatever.
Mm-hmm.
It exists where? I understand in 107, if my memory serves, it exists both on the cache manager as well as on the cache.
Yep.
So what do we want to do ourselves? Do we want to make it so that a cache that's handled by a cache manager can be actually closed by the user? Are we saying that only maybe a cache manager less cache can be closed by a user?
I would like that to be the case.
Which
because I'm trying to think, what would the purpose of having a if you have cache managers if you have caches managed by cache managers, what would be the value in allowing the user to close it? The only thing I can foresee is problems.
Yeah, me too. I'm more like around.
So there's the potential here that a cache managerless cache is a different interface.
Sorry, say that again.
There's potential here that either the cache you retrieve through a cache manager is a wrapper around the real cache, and it basically says, you try and call close, I'm going to throw exceptions at you. No, don't. So basically, you don't get to see the real cache. You get to see the cache manager's sanitized view of the real cache. Or alternatively, the cache that you have two sort of disparate interfaces potentially. Or that maybe it is the real thing. Maybe the answer is that you have two interfaces. One is cache and one is manageable cache. And when you build it with all the builder API that the cache manager uses and anyone that's using a cache managerless cache uses returns manageable caches, but all the cache manager stuff returns caches. Now the cache manager is free to return the actual manageable cache instances, but it will return them as cache instances. You choose to cast the thing hard to a type that you pretend you know, and then call close, fine, because I'm not going to spec that behavior. But that way you don't actually have to wrap the damn thing and suffer that.
Yeah, that doesn't sound.
But to me, yeah, I don't see the utility in allowing somebody to close a managed cache. Just seems like a bad idea.
Right, me too. I don't get it.
And so you would close them from the cache manager.
Yep, the only way that they get closed from the cache manager.
Yeah, right.
Well,
whatever that meant, you would let them go from the cache manager.
The cache manager closes them. Exactly what triggers that depends on the spec of the cache manager.
Right. So this is a good one again. Let's keep on going that route, and now we can go slightly in the TC world as well. So say I got a cache manager, and so I'm building a cache manager. No, I'm sort of hinting to the solution I thought about. And so, anyways, there might be different things you want to do, right? So what does it mean to close, right? So does it always mean the same thing? So think about TC again, right? So when I'm closing my cache, I'm letting go of all the local resources.
Yep. Well, hang on. What are we thinking about? Are we thinking about the Ehcache 2x here?
No. We're thinking about what we're building now.
Okay.
So
So one of the things that I labored on in the 107 stuff was discussions about in the API language about distinguishing laboring the point that an instance of the cache for a clustered cache or in a clustered environment, instances of the cache interface do not represent caches. They represent the window through which you access the clustered entity on that specific JVM.
Right, which is certainly true for us.
Which is a really important distinction because it means that closing that just closes the window.
Mm-hmm.
And well, it's not an important distinction. It's one way of handling the intersection of the clustered lifecycle and the.
So
let me do it in other ways. It just gets really messy, in my opinion.
So let me put it this way. Maybe the easiest thing to think about for now, and we can go back to cluster afterwards, is like disk using caches, right? Caches that actually do use the disk.
Local disk.
I'm being very vague on purpose. So, because we have two flavors of that, right? We have ones that use disk as a temp space, and we have ones that use disk as a persistence mechanism. Okay?
Mm-hmm.
So when I call close on the basically what I'm trying to figure out is I'm going to use the persistent one first. So I want to have a close thing that says, all right, I'm done with this for now, right? So get rid of every.
I'm done with this.
Not the disk, not the persistent stuff. The persistent.
No, I'm done with this object that represents my ability to access this cache that has an existence outside of the bounds of this VM.
Exactly. So I'm done with that.
That statement holds for both persistent, disk persistent, and clustered.
Now I want to get rid of the data on disk. Is this something we want to include in our stuff, or?
Yes. But to me, there has to be a different instance, a different interface, a different kind of object that represents that thing.
Right. Well, a different.
Well, it doesn't have to be a different object, but it has to be a different set of methods at least.
Right. That's slowly where I'm getting at. The idea that I had yesterday evening, and I'm not sure it's a good.
You have to, and then because that's when we grapple with that in 2x. Is that was there a way of sort of crowbarring in two more or another destroy kind of method that would represent some kind of higher level destruction?
Right. And so there is that, and then there is the same on the other end, right? So when you have a cache builder, and there, like, the naming becomes like really horrible all of a sudden.
Yes, are you building a cache
builder? To build all makes sense. To build and to re-get the data that's already on disk.
Right. Yeah.
We said we wanted to have a clear separation of that, right? Obviously, the code needs to be able to do something like, okay, if the thing's not on disk, it's fine. Recreate it, right? That's good. But the inverse is not always true. There might be cases where, like, I expect this to be on disk. If that's not on disk,
this reminds me of the split we talked about in the meetings we had in San Francisco. My wife says about some things might get noisy. It reminds me of the split we talked about in San Francisco, where we split the. I mean, this is not related to open source Ehcache, but it needs talking about. So, we talked about the idea of splitting the cluster config in two halves. It's the half that configures the cluster side thing and the half that configures the local side thing. And the other way of thinking about that is that there's a half of the config that deals with configuring the thing that has a longer life cycle, and a half that deals with configuring the thing that is the view on that thing that has a longer life cycle. So you can do the same thing with the objects. This idea that there's the normal cache builder doesn't, for the case of persistent or any kind of persistent or clustered cache, a normal cache builder doesn't build a cache. It just builds a view onto a persistent or clustered cache that already exists, and there is a separate builder and potentially a separate type that is the representation of that longer lifecycle thing in this JVM.
Right. So since you mentioned the world
Right.
types multiple
Alright,
times
okay.
now, so the one thing that I was thinking about is whether we want to try to do something like the stuff we did for Quartz in the 2.0 stuff, where basically the builder narrows the type of T like further down as you build.
Possibly. Although, as you're well aware, that gets really complicated and hard to write, but if you can get it right, it's kind of useful.
Yeah, so I was thinking that maybe what might be useful is to stop coding for a little bit, try to figure out like some type system, so some types and their relationships that on how we believe we would like to expose this. So stuff like a cache, maybe a persistent cache or a cache view and all those things. And you actually use the builder to do your darn thing. So if you do cache builder.build, it returns a cache period. If you do a cache builder with terracotta config build, it returns a terracotta clustered cache. You know,
which is not accessible. Well,
which is not
maybe.
accessible.
No, okay, sorry, go on, because you're talking about unioning the two types, basically.
Yeah, there would be some union at that case, and at
so
that level, right?
The terracotta cluster cache is a union of the regular cache interface, or the regular cache object, which is used to access things, and some object that represents a clustered thing with a big long life cycle.
Right. Whatever then that means again, right? So
okay.
But yes, something like that, right? So. This is why I said like narrow.
I mean, one of the reasons that I like the idea of two objects is that if you have one object with a union of interfaces, you get into weird things about what happens when that thing is, when the tighter lifecycle thing is disposed, closed, destroyed. What happens to the object? Basically, you've got this one thing representing two things with disparate life cycles, and what's the life cycle of the object? Or is the life cycle this kind of thing with two faces whereby you can destroy half of it, but the other half continues functioning?
I don't see it. So if we talk about
basically, what life cycle does the object have?
Well, think about like cache and TC cache, for instance, right? Yep. Or you could have cache and disk cache, or disk persisted cache, whichever way you look at it. You could totally have a method that says close, and the close contract is to dispose all the JVM managed resources. Does that make sense? So any file pointers, file descriptors, any open connections, any stuff that would otherwise die when the VM is
when the VM dies, yeah.
Right? So it releases all that, like all the memory it allocated, whether proactively itself or whether through the VM itself, and then like all those become like eligible GC-able references, right? So that's what close means, and then that's it. Now you have a subtype that's let's say like disk persistent cache. It could have something like destroy everything on disk method on it. And what this means is that it kills everything on disk. Now, whether we want to document that when you call this, it implies that it also delete like all the in-memory representation of whatever is on disk, I think that's perfectly fine. But then all of a sudden, what I think becomes kind of nice from a user perspective is that I can build my cache, stupid cache that uses heap only, like has no twists and whistles, just cache aside thing, does whatever it needs to do, and then I decide I want to use, and I get exposed to whatever makes sense for this thing. And then for everything that's, again, life cycle to a certain extent, right? You could argue that, given what you said, Chris, that a cache writer, you could say enable cache writer on an existing cache by providing it a cache writer at that point. That's perfectly fine. So be my guess. But now, if
Yeah.
you want to have this cache go to disk, that won't be possible, right? What you need to do is shut it down. Like you create then a new cache, you add this one line that says cache. You can keep on passing. You can just recompile, it just works. Or whether that happened through like config on disk, it just worked too. But now, if you want to use advanced stuff, you can. Right? You can change the return type of that because it did change. It's a subtype, but that's fine.
Yes.
But I guess what this calls for is trying to figure out those types.
Yep. And the
What's
contracts.
exposed on them?
And like I said, I think.
And the lifecycle methods on them and what it means.
Yeah, the lifecycle methods and how they interact. And I think there are. It's one of those things where potentially there's no perfect decision on how those lifecycles interact. But as long as you make a clear decision, it's probably not going to be terrible.
Right.
And I guess that the same discussion that we had on the close and on whether the cache is managed or not will apply to the destroy.
Yes.
Yes.
But there wouldn't be a there wouldn't be a destroy for heap only cache, for instance, right?
No. I understand. So
and then you could say for the thing on this, destroy could say delete all data.
Well, I mean,
doesn't need to be the same thing for the different.
No, I understand. But what I'm saying is that the delete all data when you have a managed cache probably is something that's triggered by the cache manager, and when you have a standalone cache. Just as with close. That would be nice to have that symmetry there. Which adds even more types, I fully agree.
No, that's not necessarily true, I think, but maybe I'm missing something. Because you... Yeah, I don't know. What I'm trying to say is I was thinking around something where you could say, all right, give me an iterable of, I guess, map entries, for a lack of a better type right now, that basically maps the alias to a given type, which could be a closable. And what you ask for is, say, give me all the persisted entries, that caches that you have, right? But you don't get them as full caches back. You get them at this thing so you can do whatever those things let you do. Does that make sense? Right? And it could be by passing the actual, like, kind of the unwrap thing, right? Think of unwrap that returns you a... I don't really want to return like a map or any kind of thing. Right? Well, you said, right, from these things, give me the setback. It gives you the setback. You can know by alias. If you want to interact with it, say it could return like an iterable of map entries of string to closable. I'm just using JDK types now to keep it simple, right? It could be destroyable if you want, right? And you ask for, give me all the destroyable, What destroyable gives you is destroy, right? So it's going to kill it all, wherever it sits, on this cluster, like distributed on many nodes, whatever. Again, let's not get hung on this, like
on the details.
Yeah, the destroyable type, but you get the idea, right?
Yep.
You get its alias. If you want to do anything with it, like get something from it first, like query it, go query it through the cache to the standard way. The only thing that this lets you do is
nuke.
In this case, right?
Yep.
Or if you would have asked for, give me like all the cluster things that lets you go to cluster topology details, it lets you do that.
It's possible it allows you to do a multitude of things, but they are all things explicitly associated with that greater entity, and they probably, and for the sake of sanity, we should probably preclude it doing anything that you can do through the normal cache interface.
Yes.
Except possibly things like you might be able to ask for things like sizes and that kind of thing.
So think of it, you end up in a situation, I guess, where you got the cache interface, where you have, say, the disk persistent cache interface.
Yes.
And you got the disk persisted or persistable interface.
I mean, what we're dealing with...
And this persisted cache basically extends the two interface, right? So it has
What we're effectively dealing with here is the same thing that anyone that ever designs like a file API deals with. The file object is our equivalent of the clustered thing, and the cache is our equivalent of the file input stream or the random access file instance. It's a view onto the data contained within the file. It's a view on the data contained within the cache. And so Java's file API deals with it by having a file object that represents the real file, and it has methods like delete and create and things like that. But it doesn't have any method of you actually looking inside the file beyond you can ask it how big it is and things like that. Things that are kind of metadata-y. But it explicitly doesn't allow you to read the file without saying, I want to access this thing. I'm not saying we have to use direct, but the thing to remember is this is not a new problem. This is so and effectively, I mean, I don't see.
But then does that reboot the close conversation and the fact that close would have you would be able to close a standalone cache, but not be able to close a managed cache?
You can close them.
A cache manager-less cache.
A cache manager-less cache you can invoke close on a method.
Yeah. But a managed cache, you can't.
I can make it so that it doesn't have the method.
Doesn't have the method, or you do it and it throws or whatever. Yes.
And then you do that through the cache manager.
And if you want to, and I think the cache manager, if you want to me, if you disallow close on a cache through a cache manager, if you disallow close on a cache returned by a cache manager, then you should also disallow destroy on the same cache. If you want to destroy, you should have to go through either it's a method on the cache manager that takes some handle to a cache, whether that's a name or could actually be the reference you have to the cache. I don't know, don't care really. Or whether you retrieve some other object that represents the longer lifecycle thing and there's a destroy that, whatever. Point being that through the regular normal interface that everyone interacts with the cache, you cannot destroy it.
Yep. Okay.
And now whether on a manager, and I would guess that on a managed cache, okay, so we kind of got to the intersection of the two things now, but to my mind, on a cache managerless cache, i.e. a manageable cache, to me, there is still no destroy. Because destroy is something related to the clustered entity, and so to me, if you, for example, wanted a clustered cache managerless cache, you would have to have handled all the gubbins to create a connection to the cluster, to create the clustered entity that the cache is a view on, to create the clustered existence of the cache. And then you would pass something that represents that into the cache when you build it.
Yeah, and you would apply the same.
And if you want to destroy it, you'd have to use that thing that you used. So you'd know about that from the outside.
Okay, so we get to have the close, we get to have the destroy handled by the cache manager when you've managed cache, and you actually don't get to have the destroy handled by the cache manager-less cache because we limit the cache manager-less stuff to only be the view that we've discussed.
No. Because
the persistent services are handled. You need to set them up outside.
Yeah.
Oh, okay. Yeah.
Yeah, because whatever the persistent service is something you give into the cache to say this is your thing you're doing persistence with.
Yeah, whether it's file or clustered or whatever, it's
a thing that you go through that to do. It's not that the user's not capable of doing it. It's that you don't do it.
No. It's just that it's not the cache doing it because the cache is just the view.
Yeah.
When it's non-managed.
And this is where, to me, it feels far more natural to start talking about having two instances to represent the cache when you've got a cache with two components with two different life cycles, two types of component. Because it makes the life cycling simpler. And it also separates concerns, because in reality, API-wise, destroy is not something you want a regular interactor of the cache to do.
Right.
So it makes sense.
And
Accidentally,
it managed.
you don't want somebody who's who's merrily running along writing their business logic, interacting with the cache, to be able to accidentally call destroy.
And the same is true with close, by the way, right?
And close,
I
yes,
agree.
to a certain extent, close. You could actually pull that out and even have a cache view that is literally just the CRUD stuff.
Because I think, I'm not sure whether it has that or not, but basically, right? Oh yes, I think JSON 107 has the auto-closable thing. It sounds kind of neat, but when you think about it, I'm not really sure where you would use that. Now, for a short-lived cache manager that you create to do something where you know cache would be useful,
Yeah.
then you throw it away, right?
Yeah, you could imagine.
In that case, I would argue in our world, go for creating those orphan caches.
Yeah.
Those could totally be auto-closable, so that whenever you try with, do all this, whatever you do.
I'm doing some kind of really
JDBC,
basically I'm doing
bunch of lookups and
in-frame, in-method memoization.
Okay.
I want an in-process. I want more than in-process. I want a thread local, in-stack cache thing. Then the auto-closable makes sense. But auto-closable becomes pretty near useless as a concept the moment that the thing lives sort of across breaks across the call tree, if that makes sense. The moment it exists outside a single frame.
Yep.
If it's not destroyed in the same frame that it's created in, sort of stack frame or method context, then it doesn't make sense. Auto-closable ceases to be useful, obviously, because you can't express it in Java.
So I guess I need to go back to the.
I mean, the only problem, going back to the builder stuff, the issue I have is that I worry that the builder API, that we might get to the point where there's tension between what the cache manager needs and what a user might need. But we can worry about that
when it happens.
And
by the way, about the builder, if we make the builder explicitly while building, say. Mm-hmm. So let's reuse cache persistent disks, for instance, right?
Yep.
I can make it so that you create your builder, and when you pass it in the config that says, this is where I expect the files to be already, you could tell it. I think Hibernate has that in the, when it does the mapping stuff, where it goes check whether all your tables are there and whatnot,
yep.
Right? And you can tell it to, create, and then
there's a whole bunch of things you can tell to drop them and recreate them and stuff if you're right. Testing.
And it's actually exactly the same stuff we're talking about for the disk, right? You could say, all right, create this and use this place there in disk, and if there is stuff there, cool, use it. If it's not there, then create it
for me. And yes.
By the way, when we close, you release all that.
Yeah, you can have it.
Or you tell it, no,
totally.
I expect the data to be. I expect those files to be there, and they need to be there. And keep them when we shut down and all those stuff. I think these are just modes.
Yeah.
Right?
Once we've got a good, strong concept of the separation of the two things with two different life cycles and what's the responsibility of what, you can start mashing them together and producing useful constructs out of them that don't actually expose the full power.
Right.
And what's more, I think those constructs will make more sense if the underpinning of them is something that has thought behind it.
Right.
It feels nice. My fear is that it feels a long way from a Java spec. But hey.
Okay,
it feels to me like what we're doing here is making the decision we've come to is making a good decision that is something that Ehcache 2x and I think to a certain extent 107 didn't do to their detriment, which is to just stick your hands up and say there is a difference. There is a missing type here that you cannot just say there is this one cache interface and it is clustered and it is standalone and it is this and that and all these things and it handles it. No, it doesn't work. They're different things. They have different properties. The type we're talking about, this type that represents long life cycle stuff, even if the type ends up merged in at some point, which I don't think it will, but if it just acknowledging that there's this extra entity is really useful. Because 107 still doesn't. 107 just kind of says, what I remember, it says if you call close, it just says, oh, well, there might be some longer thing that this doesn't destroy, but it doesn't actually cross the bridge of what you do with it.
We'll keep on looking at kind of like the onion way, right? So the thing outside is the cache that you have local on your machine, and then you dig in to get to the disk or whatnot, right? And then again, you can do the same thing as to say, all right, this says create me a clustered cache. If it doesn't exist, create it. But by the way, when I go down, me, the client, right, when I disconnect, you can drop this thing on the floor and delete it entirely.
Yep.
Right? These are just modes, actually, that you end up with.
This should, I mean, and also this is very similar to what Louis and Nishant did in the entity management stuff. Was it Nishant? I think so. In the entity management stuff in TC, this idea of there's a need to, I mean, that's, to me, the entity management stuff and the things that you're mentioning there is a manifestation of the fact that there is this missing object.
Right, but that's I think the whole conclusion from the lifecycle stuff that we did, right? So I'm going to go relook into that to be sure that we sort of know it applies to that. Make sure that it applies well to this persistent stuff, maybe to other topologies as well, where potentially it breaks down. Like even if we decide to not address certain things, at least we know where it doesn't, where it can't apply, right? Where it falls apart.
We know what the limits are.
Right. Try to document these. I'm gonna. Yeah.
One of the topologies we haven't talked about. It's not. I don't think it's one we have to consider. I don't think is what happens. So at the moment we have this very simple model where you have a client-server model. And so when we say the cache and the local thing, that's the client representation. When we say destroy, we have this other thing that represents the thing that you can destroy. That's the server representation or the disk representation. We have this idea of a single point of truth. And one thing that I think we haven't thought about yet is what happens when the become when L2 comms get broken and the L2 becomes more peer-to-peer, or the TSA becomes more peer-to-peer, or if you're dealing with Cassandra-like environment where if you're dealing with a peer-to-peer environment where there isn't the idea of saying I'm going to destroy this cache, that doesn't necessarily make sense. What does that map to? What happens if you can't deterministically know you have even in a peer-to-peer environment, because if you're partitioned and you can't access some of the partitions, what happens when they come back?
Right, exactly. So you could have this mode where you ask for destroy and you don't really know whether it was entirely done. That's what you're trying to say, right? Where it could be partially done and not entirely done. Yeah. Well, I think this is a failure mode, and that's something we need to deal with. I mean, the happy path.
Okay.
Right.
The happy path.
Well, how you then even deal with that?
Well, okay. So the issue with the true peer-to-peer environment is you actually don't know whether you can never say whether you were successful, because you don't know if some guy from out of the blue is going to turn up and say, "Oh, by the way, that cache that you thought you destroyed, I was partitioned, but I've got some data from that thing." If you destroy in 20 partitions and you think you've got it all, and then 21 turn up later and say, "Oh, we were partitioned from you, but we thought it still existed," then what happens? Because there's actually a majority of you now claiming the thing's still there. But anyway, it's a problem we don't have to worry about.
I don't think that's a problem.
It's not a problem for us.
Well, it's true that you can't necessarily, you need to know that stuff is partitioned. For as long as stuff is partitioned, you need to keep record that somebody tried to destroy this.
That's assuming that the thing that you're doing the destroy through existed at the time when it knew about the state of the full system.
Yeah.
Anyway, this isn't something we have to worry about now, but it conceivably is later when we go to partial availability.
Right.
What do you do if someone asks for it? So, the partial availability we're talking about at the moment is probably static membership initially. So you would know. But potentially in the future, there's the idea you might have partial availability and you might not even know.
Right.
But I don't know if we have to plan for that. Maybe it's just foolish to try and think that far ahead.
Right. Probably worthwhile too.
Always good to end the meeting on a down note.
Yeah. All right,
but,
so
I think
the issue that I had with the cache builder was, this like single create thing, but I think we sort of discussed that. So create if it's not there, make sure that you join. If the data is not there, consider that a fail. It basically is a configuration mode of one of the service that you provide to the thing to do the creation. So I think this still works fine. So cache builder and cache manager builder, my take is probably that cache builder returns a unmanaged cache instance, for whatever that means, as a base type, and go from there. So that's kind of good. And yeah, and then I think I need to go back to the drawing board and try to sketch those types out, like their hierarchies and whatnot, and make sure that that we can then build that this kind of the same way that we did for the quartz builders. I think it's kind of neat because, right? Because it's nice, I find. And for as long as you don't go into crazy overloading stuff, you're good at it. Yeah, anyways. Thinking about binary compatibility here, but cool. So I'll try that. How about that? So I guess I'm gonna do a little bit more clean and commit this and say that. So this is a first draft to all this. The problem is, it's kind of weird. Like the way we broke up the task is, I'm trying to build sort of the foundation work for this. That the result is very little. But the problem is, it needs to be the proper foundation for all the rest that I'm sort of not supposed to build.
Yes,
by the way, I'm going to create a whole bunch of tasks or issues in GitHub,
right,
based on what we discussed yesterday with the breakdown that we want to have. And then I'm going to do a peek in all of these and make sure that the plan that I have sort of works, and validate that. So next week I'll either come with more issues or a sketch of a plan, and then happily move on doing that. So it looks like that what I'm talking about calls actually for a new wiki page on GitHub that tries to describe this evil plan that we have now, right?
Yep. Makes sense.
Cool. So I'll do that, and I guess that's it then again. Woot. Well, it all sounds good. I'm sure the future doesn't look that bright.
We didn't tear too much stuff apart, and we actually have plans for how to build some more stuff. So
what?
We actually made positive progress, I believe.
Oh yeah, on paper or.
Yep.
Make progress on paper really fast.
All right, cool. Let's try and do this. I think this might actually look good. I might try to put a prototype together of like some examples that show that. I'll put them on the wiki. They're probably going to be on my desktop somewhere, like in the IDE. I know that it really works, but I'm not going to commit that. Probably create a branch for me to go weld. I could push it to my repo on GitHub to share it along the way. So I sent a couple of updates to the mailing list about that. But I kind of like it because it keeps like the whole modularity approach that we thought about, and how it remains extensible and whatnot. We just need to be careful with the basic building bricks here.
Yep.
All right, cool. Well, thanks, and
thank you guys.
talk to you later.
See you.
Bye.
Bye.